Hi, this is Vernie, and today I will be talking to you about Pythagorean theorem. But before that, let us review first the classifications of triangles. So this time, we talk about classifications of triangles. Triangles are classified according to the size of their angles and the length of their sides. According to the size of their angles, triangles can be acute, right, and obtuse. Acute triangle has angles less than 90 degrees. Right triangle has at least one 90-degree angle. An obtuse triangle contains one angle more than 90 degrees but less than 180 degrees. According to the length of their sizes, triangles can be isosceles, equilateral, and scalene. Isosceles has two equal sides, equilateral has three equal sides, and scalene with no equal sides. So today, we will talk about Pythagorean theorem. Pythagorean theorem is named after the ancient Greek mathematician Pythagoras. This theorem states that the square of the hypotenuse of a right triangle equals to the sum of the squares of its two legs. That is, c squared equals a squared plus b squared. So this is an example of a right triangle with a as the altitude, b as the base, c as its hypotenuse, and of course the 90-degree angle. So the first example is a triangle with legs 4 and 3 and the hypotenuse as the missing side. To find c, we will use the formula c squared equals a squared plus b squared. Substituting the given values, we get c squared equals 4 squared plus 3 squared. Simplifying further, we get c squared equals 16 plus 9. Adding the two values, we get c squared equals 25. To find c, we will extract the square root of both sides. So we get c equals 5. Therefore, the value of c equals 5. Now, let us look to our next example. As we can see at this figure, the missing side is the altitude. When one of the legs is missing, we have to subtract the square of the given leg from the square of the hypotenuse. So in this case, we will use the formula a squared equals c squared minus b squared. Substitute the given formula, we have a squared equals 17 squared minus 8 squared. Simplifying further, we have a squared equals 289 minus 64. Again, we have a squared equals 225. Extracting the square root of both sides, we get a equals 15. So the side A measures 15 units. And for our last example, we have this figure, and this time again we will solve for c. Again, we use the formula c squared equals a squared plus b squared. Substituting the given values, we get c squared equals 4 squared plus 8 squared. Simplifying further, we get c squared equals 16 plus 64. Adding them, we get c squared equals 80. To find c, we will extract the square root of both sides. So we get c equals square root of 80. Since 80 is not a perfect square, so we have to find a factor of 80 that is a perfect square. So we get c equals 16 times 5. Taking out the square root of 16, we get 4 square root of 5. So the final answer is 4 square root of 5. Okay, so let's try this one. The diagonal of a rectangle is 25 inches. The width is 15 inches. What is the area of the rectangle? So this is the illustration of this problem. So in this problem, in order to find the area of the rectangle, first we need to solve for x, or the base. So we use the formula x squared equals c squared minus a squared. So x squared equals 25 squared minus 15 squared. Simplifying further, we get x squared equals 625 minus 225. Subtracting the two values, we get x squared equals 400. So extracting the square root of both sides, we get x equals 20. So this is the measure of the length of the rectangle. So now we will solve for the area. So the formula for the area of the rectangle is area equals length times width. So area equals the length, which is 20, times the width, which is 15. So area equals, so the area for this rectangle is 300 inches squared. To fully understand our topic today, we must apply this theorem in word problems. So I have here examples. Number 1. An isosceles triangle has congruent sides of 20 cm. The base is 10 cm. What is the height of a triangle? So we have here the illustration of the condition stated in the problem. In this problem, we are asked to find for the height x. As we can see, the base of the isosceles triangle is 10 cm. To solve for x, first, we have to find the base of each right triangle of this isosceles triangle, and that is 5 cm. 10 divided by 2, since there are two right triangles. So we are now ready to solve for x. Again, using the formula x squared equals c squared minus b squared. Substituting, x squared equals 20 squared minus 5 squared. Simplifying, x squared equals 400 minus 25. So x squared equals 375. Extracting the square root of both sides, we get x equals square root of 25 times 15. So x equals 5 square root of 15. So the height of the triangle is 5 square root of 15 cm. Number 2. A soccer field is a rectangle with 90 meters wide and 120 meters long. The coach asks the players to run from one corner to the corner diagonally across the field. How far do the players run? So here is the illustration of the problem. So in this problem, we are asked to find for the distance traveled by the players. So we must call this distance x. Now we are ready to use the formula x squared equals a squared plus b squared. Substituting, we get x squared equals 120 squared plus 90 squared. Simplifying further, x squared equals 14,400 plus 8,100. So we get x squared equals 22,500. Extracting the square root of both sides, we get x equals 150 meters. So the players run 150 meters from one corner to the corner diagonally across the field.
That's all for this video, and I hope that I'm able to help you in your study. Again, this is Vernie. Thank you for watching, and don't forget to practice. Bye!